Hello! In this video, we're going to talk about the natural base e. This is lesson 5.2 from your textbook. So natural base e is an actual irrational number just like pi. So it's equal to, if you use your calculator and you type in e to the power of 1, you wind up with something that looks like this. Now it looks like it stops. It actually doesn't and continues to go forever. You don't have to have this number memorized. You're just going to use it in a formula, or you might need to manipulate it when you're working on equations. Okay, so what does it look like when you graph something that has e in it? Well, e, it's going to have an exponent. So it's going to look like either exponential growth or it's going to look like exponential decay. So there's a couple of things that you need to learn. It's pretty easy. So if you know that you have a positive exponent, so if r is greater than 0, it's going to be positive. That is going to have an exponential growth. And on the other hand, if r is negative, then that means that you are going to have an exponential decay. Now these look just like the exponential growth and decay that we talked about in lesson 5.1. You have an asymptote right here at x's, where x's or the x-axis, if I could say it right, where y is equal to 0, okay? So we want to practice doing a couple of sketches, just try to figure out if it's a growth or a decay, and you are welcome to use Desmos to help look at it and figure out our end behavior and our y-intercept. Okay, so let's look at example number A. We want to figure out if this is a growth or a decay. Now, if you look at your exponent, that is a positive 1x. So if it is a positive x, that means that this is a growth. And I know it's going to look something kind of like this, but I want something a little bit better than that. I also do want to point out that your a, or your initial value, is 3. That is going to be your y-intercept. It will be your y-intercept as long as you don't have anything added or subtracted from this, translating it up or down. So let's graph it in Desmos and see what it looks like. So I've typed in 3e to the power of x, and this looks exactly as I expected. It has that growth pattern. You can see that it looks like it gets closer to the x-axis, but it's never going to get there. And your y-intercept is exactly where we predicted it at 0, 3. So let's go back over to our notes and write a few key things down. Y-intercept and our end behavior. Okay, so I know that it's going to hit at 3, so I'm going to show some kind of a growth like that. Should do this. Here we go. Now that's my y-intercept. I want to write down end behavior, and it's been a while since we've done end behavior, but you're going to write as x approaches infinity, and remember infinity is over here on the right. So what does the right arrow do? Well, it goes up. So that means y is going to go up, which is positive infinity. Now you've got a different direction, negative infinity, which is to the left. So as you go to the left, what happens is, yes, it is going down, but it's not going to continue to go down to negative infinity. So negative infinity would be well past the x-axis. It's actually going to continue to get closer to the x-axis. That means y is going to get closer to 0. It gets closer to 0, but it never actually touches 0. All right, let's look at B. This one's different, obviously, because it's got a negative exponent, which means that this is going to be a decay. It should look something like this, all right? I don't see an initial value, which means there should be a 1 in front. So my y-intercept should be a 1 because I don't have any translations up or down. I'm going to go ahead and start this. I know it's going to hit at 1. I'm going to click on Desmos, and we're going to change it to negative 0.5x. Let's get rid of the 3. Okay, and it looks exactly as I expected. It hits right here at 0, 1, and it gets closer to the x-axis. Back to notes. So I'm going to go ahead and copy this in here. Just make sure that this doesn't hit your x-axis. So all I have to do now is write down my end behavior of this decay. So as x approaches positive infinity, it looks like it's getting closer to the x-axis. So if it gets closer to the x-axis, it's going to approach 0. On the left-hand side, as it goes This direction, it goes up, and it's going to continue to go up, 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 up. So it's going to hit positive infinity up here. So for the next section, this is an honors specific section. I'm going to do this at the end of the video. So let's go on to compounded interest. This one is a new formula. It is continuously compounded interest. This is different because compound interest can be defined by like quarterly or annually or daily. Like n can be equal to a specific number. If you are continuously doing something, you can't define that with a singular number. So you cannot have n in your formula. What they do is they use e. So there's some really cool videos on YouTube that will show you how they came up with e, but we just don't have time to talk about it in today's lesson. So y'all can just look that up on your own if you want to. Well, anyway, so this first little example here on A, it says account 1 pays 4% annual interest compounded monthly. So that's kind of a key word that tells me that I'm going to be using this formula up here. And then it says, what would be the balance in the account after 2 years? So I know it's monthly. I know it's going to pay 4%. I know it's going to be 2 years. What is the balance in the account? Oh, also skipped that part right there. It's really important. So you got $5,000 in the account. So let's take a few notes. So I'm looking for the amount after 2 years. So T is 2. It is compounded monthly, so n is going to be equal to 12. Your rate is 0.04. You are going to be using this formula in this example. So your principal is 5,000. Your rate's 4%, compounded 12 times, and then make sure that you write it up here in your exponent times t of 2 years. All right, go ahead and type that into your calculator and let's see what we get. So since it's money, I need to round it to decimal places, and I wind up with $5,415.71. Okay, on to the new stuff. So this example says account number 2 pays the same annual interest, but only it's continuously. So if it's continuously, we need to use this formula right here. All right, so this one's actually pretty easy. You only have a few things, unlike the other one's got a ton of things that you've got to plug in. So your principal is still 5,000, and then your rate is still 4%, and you're leaving it in for the same amount of time. Now, if you don't know where E is on your calculator, let me pause the video, and then I'll bring up the calculator and show you where it is. Okay, so E is right here above that LN button. So all you have to do is hit second LN. There it is. So you're going to type in E to the power of 0.04 times 2, but I need to type in 5,000 first. And then we're going to do E 0.04. So your calculator knows you're going to do an exponent. And then hit times 2, and then hit enter, and then that should be our final answer. Let's write that down. There we go. So it's really not that much different. So everything is the same in A and B except for this one's compounded monthly, and then this one was compounded continuously. So this one says, what's the difference between the two accounts after, it should say 2 years. So we've already figured out how much money's in the account after 2 years. All you have to do is subtract these two numbers. So subtract this number, subtract, ooh, that went crazy. Subtract this number, and this number right here. Oop. Like that. You always want to write the biggest number first, and then you wind up with a grand total of 73 cents difference between the two. Now this one says, how would your answer to part C change if you invested $50,000? Well, you would do exactly the same thing, except for instead of using P equals 5,000, you're going to use 50,000. So Here's how your equations are going to look different. Okay, so that is the part that's different. And then the compounded continuously. And if you type them in your calculator, this is what you get. Oops. Subtract these two numbers in your calculator, and the difference is going to be $7.20. So this question is it's really typical of a benchmark or an EOC, not an ACT, but an specifically Algebra 2 question. It wants you to compare a formula, equation to a graph. So here's your graph over here. These are not the same thing, all right? So this is your account, this is your friend's account. So these are going to be different from each other. I want you to pause the video. I want you to see if you can figure out which account, your account or your friend's account, which one has the greater principal. And then I need you to figure out which one has a greater balance after 10 years. And you're going to find that in different ways because one's an equation and one's a graph. So pause the video now. Answer those questions, unpause the video to see if you're right. Okay, to see who has the greater principal, all you have to do is look at this starting amount. So your account will have $4,500 in it, but your friend's account, which is the graph, has $4,000. So which one has the most money in it? Your account has the most money, but that's just at the very beginning, okay? So this one says after 10 years. So 10 years means T is equal to 10. So the only way that you can figure out how much this account has is you're going to plug in 10 for T. So when you plug that into your calculator, you wind up with about $6,700, a little bit more than that. Now this is your account, but your friend's account, which is the graph, where is 10 years? So this is years. Where is 10? This is 10. So you need to track up here and figure out where this is. Now, all you've got to do is make sure that this is either more or less than how much you have in your account. But if you track it back over here, it looks like you have, well, that's going to be $7,000. So it's going to be at least over $7,000 according to the graph. Who has more money after 10 years? Your friend does. And that's it. All right, so if you're a regular student, you can stop watching the video now. But if you're honors, let's do some equation manipulation. All right, so what we're going to do is we're going to figure out the percent change. As this is, I can't really tell what our growth rate is going to be. So I'm going to separate this negative 0.5 from the x. And we're going to evaluate that in our calculator. So if you type that in the calculator, you're going to wind up with 0.6065. And you're probably thinking, well, where's the rest of it? Remember, if you don't see anything in front, there's a 1. That means your original amount is 1, and it is going to decay. Now, I knew it was going to decay because that was negative, but it's going to decay because that's definitely less than 1, okay? So then you need to rewrite it as 1 minus. Just type it in your calculator, 1 minus 0.6065. It's going to give you that magic number. And you wind up with 3935. If you write it in this form, that is going to be your percent change. So the percent change is going to be 39.35%, and that will be a loss. Okay, over here is a positive exponent, which means it's going to be a growth. You're going to see that in just a second. One thing you need to understand that this 2 is not part of your base, that 2 is the A or the initial value, separate it from the E. Do not include that when you manipulate your equation. It is going to remain in the front unchanged. So the 2 is now separated from the X. One more time, please do not put 2 in with the E. It is separate. So when you type that in your calculator, leaving 2 as it is, we are going to put E squared only. That is 7.3891. That is a huge growth. You need to write it as 1 plus something, not 6 plus something. You're going to write it as 1 because that is your model. So 1 plus 6.3891, and this is your answer. You have to change it to a percent. No, it is not 6%. Remember, to change a decimal to a percent, you have to move it 2 decimal places. So it is 638.91%. So be really careful when you do something like that if it's a huge growth. And that's it for the video.